remember your exponent laws from grade 9? Like here is an exponent law. If you had 2 cubed times 2 to the 5, it's equal to 2 to the 8. And it should make sense because 2 cubed is just 2 times 2 times 2, and 2 to the 5 is 2 times 2 times 2 times 2 times 2. And in the end, you would have 2 times 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 2. And you count, oh, I have 8 2's all multiplied together, so that makes 2 to the 8. So the law says if your bases are the same, you could just add your exponents. And it works even with fractions. So if I have x to the half times x to the half, that would be x to the half plus half, which is just x to the, oh, how do we add fractions?
Oh, half plus half.
Half plus a half? It would be a whole, right? Keep the denominator, it would be 2 over 2. It's going to just be x to the 1, so we don't even have to write anything. Okay? And if you took the square root of something and multiplied by a square root of something, that would equal the square root of x squared. And if you had 2 x's inside, what does that mean you can do? You can bring one of them out. That would just equal x. Does that make sense? Like if I had square root of 7 times the square root of 7, that's going to be the square root of 7 squared, which is 49. And what's the square root of 49? 7. Does it make sense when you multiply a square root by itself that the square root would go away? Because you're technically squaring a square root that's undoing what you're doing. Right? I could ask you things. I want the following answer without a calculator. I'm going to give you some mental math. Okay? And you have to give me all the decimal places you can to the end. Okay? Your mental math ready? This is going to have 2 steps. You're going to take 11. You're going to square root it. So, there's no writing down, all mental math. Okay? Keep as many decimal places in your head as possible. Of whatever answer you get, square it. So I started with 11. You square rooted it. Kept all the decimal places you could in your head. Now square that answer. What do you get? 11. Do you need to know the in-between part? No, you could cheat a little bit. Because those two things undid each other. Right? It's the same thing if I said, okay, take 537, divide by 7, now multiply by 7. Right? What did you get in between? It's a good question. Because you didn't do the in-between part, right? Because the in-between part was hard, but you realize that some things cancel each other out, and they're like a shortcut, right? Squaring and square rooting cancel each other out. Can you see that I could write this using my square root rules that say a square root times a square root, you can multiply inside and get x squared inside, which is x. Or I could use my rules this way and say a square root times a square root. Well, that's 2 square roots multiplied by each other. That's squaring something. So this and this are written different, but end up being the same thing. Okay? Very nice. Now, if we wanted to get really fancy in math, there's tiny differences, but we won't worry about that right now. Okay. So, if x to the half times x to the half is x, and square root of x times square root of x is x, and this was the same thing times the same thing equals x, and this was the same thing times the same thing equals x, does this make sense as a result? They have to be the same. And I kind of cheated by showing you this already. Right? We did in our warm-up 36 to the half, and some of you remembered from the previous class that that was the same as the square root of 36. And we discovered that by playing around on our calculator by testing things out. So if you had the square root of 1/3 times the square root of 1/3 on your calculator, and you type that in, you would get 1/3. And if you did 1/3 to the 1/2 times 1/3 to the 1/2 on your calculator, or used your exponent laws that said, I can just add my exponents, you would get 1/3. So it works that a square root is the same as an exponent of a half. And you can now go to your calculator, and sometimes, maybe on your calculator, my square root button, I have to push the second button to get it. How many people have calculators where the square root button is hidden? Like I have to go second square root to do square root of 8. You get 2.828. I have to push the second button. But I don't have to push the second button for my exponent button. 8 to the 0.5, boom, same answer. Okay? Some of you have hard places to find your cube root button. Like I have to go hit my math on my calculator and go down to number 4 to do the cube root of 10. Well, I'll do 9. That's good. Cube root of 9. It's not 3, 2.08. Right? Because cube root is something times something times something. Cube root of 9 is 2.08. But I could also do 9 and type in 1 divided by 3 up here and get the same answer. So sometimes the fraction one is nice on your calculator, sometimes the square root is nice. On this one, you hit the math button, and the fourth one is a cube root. The fifth one gives you any root, so I can do the sixth root of 25, 1.7. I can also do 25 to the exponent of 1/6 and get the same answer. So here's the general. An exponent of a half is the same as the square root. And we could look at our exponent rules if you were using your exponent rules and adding the exponents. 5 to the 1/3 times 5 to the 1/3 times 5 to the 1/3 would be 5 to the 1, which is just 5. And the cube root of 5 times the cube root of 5 times the cube root of 5. You could either write this as the cube root of 5 cubed, or you could write this as the cube root of 5 times 5 times 5, 125. Either way, this one, the cube root and cube cancel each other out. This one, you're like, oh, I have 3 5s inside and I'm doing a cube root. I can pull 1 out. This would be equal to 5. And as a result, we can say that it must be true that the cube root of 5 is the same as 5 to the 1/3. Yes?
I thought when you multiply exponents, they add.
They do. So that's why I wrote, I'm multiplying exponents, and I added 1/3 plus 1/3 plus 1/3.
Wouldn't that be 6 then?
Yeah.
How do you add fractions? Right? This is like the most important thing in our fraction rules. You need a common denominator. Do they have common denominators? Yes. Then you just add the tops. 1 plus 1 plus 1 would be 3 over 3.
Wouldn't that be 6? Yeah.
3 over 3 is equal to
1. But then we have 5. No?
5 to the exponent of 1.
Which is 5.
So 5. Oh, okay.
3/3.
Yeah.
I knew it's 3 over 3, but I just thought it was you're adding it, so I thought it was 6.
Yeah, so you see how you, oh, we were talking about this in our class this morning. Sometimes your brain plays tricks on you, where like exponents has an adding rule, and you saw the 5 to the 1, and you just went 5 plus 1, that's 6.
Yeah.
Right? But that's not the rule there. That's your brain playing tricks on you, taking one rule and doing something else. lovely things the brain. Like, I just want it to work the right way, but it doesn't always do that. So we can take each of these now and realize the pattern that a quarter would be a fourth root, a fifth would be a fifth root, and we can generalize this works for any number that n would be an nth root. Any natural number. Remember this symbol? That means natural numbers. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. I'm going to give you an order of operations puzzle. Okay? I want you to tell me what this is equal to and what that is. What does the half mean? Square root, right? So it's just square root. This is negative square root of 9.
Which is like the 2 point.
Which is square root of 9. Oh, you're overthinking here.
3.
Is 3.
Wait, what was the 2 point from?
That was the cube root of 9.
It would be
Negative 3. Because order of operations, you would do the exponent before you multiply. So we do the square root of 9, and we just get 3. And this one would mean the square root of negative 9.
What's that like? E thing?
This notation means that n, that E thing means belongs to the natural numbers. It's an E because technically, a fancy math word for something belonging to a set is an element. So we have the E thing as sort of is an element of, but it means that n is a natural number. Is the shortest thing I could define the E as. No, we're not finished with the last one. What's this equal to?
Why is the negative sign on the outside versus the inside?
Because of order of operations. Order of operations say you do exponents before you multiply. And this half is an exponent to the 9th. The half is not then an exponent to the little invisible negative 1 that's multiplied in front. Okay? No. The square root of 9 is 3 times by a negative 1 would give me negative 3. But this, you can't take the square root of a negative number unless you use imaginary numbers. We're not talking about imaginary numbers now. Yes.
Where did you get the 9 from?
Where did I get the 9 from? I just made a question up. I just said, if we had this, can we figure it out? If we have the other one, can we figure it out? They look very similar. One has brackets, one doesn't. One is possible, it's equal to negative 3. One is not. It's not possible because you can't square root a negative.
Oh.
Yes. We're not allowed to square root a negative because we would be looking for the same number multiplied by itself equal to negative 9. So if you thought, oh, negative 3, but what is negative 3 times negative 3? Positive.
Sorry for the interruption.
You're like, oh.
Grade 12 student with the last name that starts H2M that need a picture retake, please head down to the library. That's grade 12 student with the last name that starts H2M that need a picture retake, please head down to the library.
So, for the math that we're doing, this is not possible. There are some maths out there that you need to make this work. And so they have invented imaginary numbers to make this work. So if you look it up online, you will see some places they will say that the answer to that is 3i, where I is an imaginary number. But let's do these ones. Hold on. For some parts, but these would be non-calculated, definitely non-calculated. You need to know your times table. So, can you see yourself having to do this at the beginning? You're probably better at square roots than you are at fraction exponents. So you might have to do that first. Then you might be able to figure them out. What is the square root of 49? 7. Are you allowed to cube root a negative? Or is this not possible?
You can cube root it.
You can cube root a negative. Because a negative times a negative times a negative is negative. And this will equal negative 3. Same thing here. Negative 2.
So then why were we allowed to do it in the 9 example?
Because it's a square. Square. So if you
That's a good question. Someone
I'm not gonna remember that. Okay, so then
don't remember it. Make it make sense. Why can't you square root a negative number? Why is this not possible?
Oh, because it's
Because
9.
if you tried to do negative 3 times negative 3, it does not equal negative 9. And if you tried to do 3 times 3, it does not equal negative 9. And no matter what you try,
3 times
you will never get, when you square something, a negative number.
that makes sense.
Will you have to remember it, or does it make sense? Right?
Okay.
Right? If we can make it make sense, but can you see that if I did a negative times a negative times a negative,
That equals negative.
so cube roots are possible.
So then,
Fourth roots won't work. Fifth roots will.
6,
Sixth roots won't.
7,
Seventh
yes, 8,
root.
no, 9, yes, 10, no, 8.
So how would you generalize that? Which roots work, which ones don't?
Even numbers don't work, odd numbers work.
Perfect. Even ones won't, odd ones will. So you could check something like this and do this question in your head. The 1048th root of negative 3 is not possible. Because it's even. That looks pretty impressive though, right? Your friends that are taking grade 10 pre-calc next semester, he's like, I can figure this out in my head. Don't tell them the answer. They're like, whoa, that looks hard. And you say, it is. Do you remember this power rule?
Yeah.
That if I had 2 to the 7 to the 5, how many 2's would that be in total?
12. No, 35.
35 of them. Because can you visualize that 2 to the 7 is 7 2's? Can you see that in your head without writing it out? And if you had 5 of those things, 7 2's. 7 2's. 7 2's. I need long might write my too big. But can you see that you would have 35 of them?
Yeah.
And if you can see that with the 2's, then you can remember the rule. And then we go crazy with the rule because we start using the rule with numbers you can't see in your head as well. So for example, this one's easy. I bet you can visualize 2 x's in the inside. And I bet you can visualize those 2 x's 4 times and see that there's going to be 8 of them. But I'm pretty sure you can't visualize this in your head. How many x's are there? There's an x to the 3rd, and then that's to the 2 7ths.
You have to find a common.
You don't need a common denominator. What's your rule for multiplying fractions?
You just multiply it.
Just multiply the tops, multiply the bottoms.
2
2 on 21.
Oh, yeah, but it's,
Multiply the bottom.
no, we can't simplify that.
There's not,
Oh,
2
yeah.
on 21
So
cancels.
multiply the tops and multiply the bottom?
Multiply the tops, multiply the bottoms, that's your fraction. Uh-huh. Okay. So, watch this. x2 on 21 will be the 21th root of x squared. Does that make sense? That the fraction gives you your root, and you would have x squared inside. Okay, so our power rule makes sense when it's nice numbers and you can visualize it. Use nice numbers to help you remember the rules. Because I'm going to tell you that your brain's going to get mushy when it gets to stuff like this. Okay, mush stuff. Because it's going to be like, oh, what's the rule? Think back to regular numbers, you'll remember the rule, and then the cool thing is we can apply the rule to not nice numbers. So now we can evaluate things like this. Four to the 3 halves. Yeah, you're like, it's not that bad.
No, I don't.
Because you've learned already that the half is a square root. So we have options here. We can either think like this. This is the better option. Can you see that 3 halves is 3 times 1 half? Or we can think like this. Because 3 times 1 half is the same as 1 half times 3. So I'm using my power rule to break this up. Why is this helpful? On this one, this would mean I would have the square root of 4 cubed. And on this one, this would mean I would have the square root of 4 times 4 times 4, 64. What's the square root of 64? 8. What's the square root of 4? 2. What's 2 cubed? 2 times 2 times 2? 8. Which one do you like better as the first example?
Second one.
Okay. Which one do you think is better? First one. Cool. You like the second one better? You think the first one's better? So, isn't that how math always works, right? Whatever you like better, they're like, no, all you have to do is, right?
Yeah, like
Like,
grouping
oh.
method.
Like grouping method. I don't know. I still like the other method. Arguments for the first one being better. What's the biggest number you had to work with? We had to do mental math with the square root of 4, which is, and then you got 2, and then you had to cube 2. So this one involved cubing 2, this one involved cubing 4. So a little bit harder, okay? sometimes you might get, with bigger numbers, math becomes a little bit harder. So if I gave you this question, 64 to the 3/4. No, I'm going to not do 3/4. I'm going to change it to 2/3. Make the numbers a little bit smaller. Your options are either the 1/3 first and then squaring it, or squaring first and then the 1/3. Mental math, can you do the cube root of 64?
4.
It's 4. Good. And 4 squared is 16. Wonderful. Okay? Can you do 64 squared? Because if you can do 64 squared in your head, you're going to be fine. Probably not? No? I'm going to take it to guess. I think it's 4,096. And then you have to say, what times what times what is 4,096?
Let's say 16.
16. I don't even know if those numbers are right, because this mental math is harder because we had to deal with bigger numbers. So generally, if you can do the square root or the cube root first, your life was probably going to be easier because you're dealing with smaller numbers rather than dealing with the bigger numbers. You guys are not very helpful for me. Nobody checked? I want to
You're
keep.
right.
I was right.
Yeah.
Okay, thank you. Yes.
So what was the cube root of 64?
The cube root of 64 is 4, because 4 times 4 times 4. So in our notes a while back, we had a list of perfect cubes and a list of perfect squares. 64 is on both lists. Kind of cool. It's the first one on both lists. It's also a perfect power of 6. Because 2 times 2 times 2 times 2 times 2 times 2, 2 to the 6 is 64. Okay. Evaluate. 32 to the 2/5. Figure out which method's going to be easier for you mental math-wise. All right, how did you do? Did you figure out that you should do the 1/5 first? Yeah. And the 5th root of 32 is 2. It's 2 times 2 times 2 times 2 times 2 is 32. And then you square it and get it. And I was showing you this the other day, and I think it's pretty cool, that if 32 is 2 times 2 times 2 times 2 times 2, and I take a fraction of that, 2 out of the 5, I get 4. $64 is 4 times 4 times 4. If I take 2/3 of that, I get 16. And 4 is 2 times 2. Another 4 would be 2 times 2, but if I take 1 1/2 of them, I get it. I think that's pretty cool. So in general, if you have a fraction, you can either, right, if I have 9 to the 3 halves, I can either do 9 to the half cubed, or I can do 9 cubed to the half. But generally, we like to do the half first. Here's something that is, there's a note there, because sometimes life gets crazy in math, and arguments happen. There are math arguments. Here is a math argument. First of all, if I have -3, and I have this to, let's say, what would be a good way to do this one? Yes. And I had -3, and I had this. What do you notice about those two? They're the same. I like that idea. They're the same. Because 3 on 2 is equal to 6 on 4. Then, if they're the same, would you agree that if I did this, and I did this, lots of brackets, that's the same. That's just my exponent rule, right? I multiply my exponents, that works. I multiply my exponents, that works. If I simplify inside, -3 times -3 times -3 is -27 to the 1/2. And if I simplify this one, what is -3 times -3 times -3 times -3 times -3 times -3? Positive 729. This is the square root of -27. This is the 4th root of 729. What's going to happen if I type this into my calculator? It's going to give me an error. I can't take the square root of a negative. But what if I do this in my calculator? I get a number. Well, what happened? I thought we started with the same thing. There. This one's impossible. This one's possible. What happened? The fraction isn't reduced. And what happens if I did this one? I did this first. Then it's not possible. This is a problem in math. What do you mean? You could do something some way it's possible, something some way else it's not possible? What should it be? Should it be possible or should it be not possible? Should be not possible. So what they've said in math is that if your fraction isn't reduced, you could do math that's actually not possible and make it possible. which is impossible. Yes.
So if it was like 8/12 with the fraction,
Yes.
could you simplify it to,
Oh, I like this one. -27 to the 8/12.
but then could you simplify the fraction to like 4/6? 3/4.
How about 2/3?
2/3. That's what I meant. And then you just.
And then we
do
could
the
see if we
exact
could
same
do it.
thing?
And would that one be possible? It'll be a cube root, and you can cube root negative numbers. So that'll equal +9 when we're done. Yeah.
This is some water.
Yes. Yeah, well, your brain starts to overheat and you put water on it to cool it down.
Yeah.
I totally understand. Okay, so this is playing around with our exponent rules. We need to know our exponent rules from grade 9 so well, because now we start switching them to variables and fractions when they don't make sense in our brain. So we need to know our exponent rules well for our regular numbers, where they make sense, so that we can apply them to new rules that don't make sense. So what would I have to do here? I would first have to make sure that that fraction's in lowest terms.
Yeah.
Is this possible or is this impossible?
Possible.
It is possible because this would be the cube root of -8, and the answer to the cube root of -8 is -2. If we didn't simplify this, most likely we would go, it's impossible. Because if you didn't simplify it and you wrote it like this, right? You would get the 6th root of -8 and say it's not possible. That would be a problem. If you didn't simplify it and did it like this, you would get +2 and get it wrong. So depending on which math rule that we use, we either get not possible, +2, or -2. This one is wrong. This one is wrong. This one is right. So there's a reason why we simplify things, and in some cases, if you don't simplify things, you actually get wrong math, which is probably the best reason you've ever heard for simplifying fractions. Up till now, it's just like, oh, this is something we have to do. I get 5 on 10, I have to write it as 1 on 2, because that's simplified. But now we see a reason why that comes up. So one of the things that gets asked of us is, can we take something in radical form and switch it to exponent form? Okay? Probably you're going to get to the point where you can do this directly and write 3/4. If you wanted to take an extra step, the 4th root is a 1/4. You would have 1/4 to what's inside, and then you would use your exponent rule that says an exponent to an exponent, I multiply. Have to know our rule for multiplying fractions. How do I multiply fractions? I multiply the tops, I multiply the bottoms. 3 times 1 is 3, 1 times 4 is 4. And we start to see how grade 10 really takes all the stuff you learned up into grade 9 and just takes it to that next level. For this question, you need to know exponent rules, fraction rules, multiplying rules, all together in one. And that's going to happen more and more. So when you find, this is the nice thing about grade 10 math though, when you find something where part of your skills get exposed to be maybe less than adequate, like, ooh, my times table is not as good as it should be. My fractions rule is not as good as it should be. That's telling you, hey, this is an opportunity, go home tonight, practice that. Learn that better. Learn your fraction rule better. Learn your times table better. Because you're going to set yourself up either for success or, and this is what a lot of students do, is like, oh, I'll leave that for later. That's going to set yourself up for not as much success, right? Do you want to get through to be able to do university math when you get to university? Or do you want to not have to do any math when you get to university? Or do you not want to go to university? These are all valid options that a person can do, right? You can go to university and take courses that have nothing to do with math, right? And then you would say, well, these are the kind of jobs that I want to do, and lots of people, that's what they're interested in. If you want a job where you need math involved, then the stuff that you do now sets you up for that success. And if you are like most students who in grade 10 have no idea what job they're going to be doing when they're 30, right? Most students in grade 10 don't know what job they want. Lots of things affect your life that change it. Then I would recommend do everything you can to the best of your ability so that you have all of your options open. Okay. We did this one already, right? This was the same example as earlier. We skipped this one, because it's 8.
What about the,
Oh, yeah.
Did I skip another one? I did that one. Here. It's x to the 3/4. Oh yeah, we'll end with this one, then we'll get our quizzes back. 2b cubed to the 1/3. Do you remember your exponent law if you had something like this? When you have two things and you have an exponent. Does it make sense to you that this would be 2x times 2x times 2x? And so your exponent law that you remember from grade 9 is that the cube goes to the 2 and the cube goes to the x. This should make sense based on looking at a simple example. But when you have fractions, you can't visualize that as well. But the rule is still there that this 1/3 goes to the 2 and this 1/3 goes to the 3. And 1/3 times 3 would be 3/3, which just leaves you with b. 2 1/3 b. Okay? Or, wow, that's not what I want to do. Here we go, we're going to move these over here. Check this out. Can you see that you could have also done this? And the cube root of b cubed is, you could have started by writing it as a mixed radical. And then, we tend to write our numbers first and letters second. But b times 2 to the 1/3 is the same as 2 to the 1/3 times b. Okay, we're going to get our quizzes back.